Hello, everyone. Thank you for joining today's webinar. We're still waiting for more colleagues to join us, and we will start shortly. Good afternoon, good morning, and good evening to everyone. We welcome you all, particularly those of you joining from far away or at late or early times. Thank you for joining this WHO EPI-WIN respiratory syncytial virus genomic surveillance, how and why. For those new to EPI-WIN, this is the WHO Information Network for Epidemics for Science and Knowledge Translation in Health Emergency. Our goal is to translate science in accessible, understandable, and relevant ways for evidence-informed actions and decisions in health emergency preparedness and response. Today, we have a great panel of experts to discuss respiratory syncytial virus, or RSV, genomic surveillance, the how and why. My name is Lester, and I will be hosting today's webinar. To give you a quick overview of what to expect today, you can find the list of speakers being shown right now. We will hear from Dr. Sidhi Hirve, Technical Officer from Global Influenza Program, WHO Geneva. He will give us the welcome remarks. Then we will hear from Dr. Thomas William from University of Edinburgh, UK. He will give a talk on RSV genomic surveillance, operational considerations. And then we will have Dr. Sebastian Bauder-Straw from GISAID Data Science Initiative. He will give us a topic on leveraging RSV genetic sequence data for public health. After that, we will have an interactive question and answer. It will be moderated by Dr. Obadiah Fu Kenji from Global Influenza Program, also from WHO Geneva. Before we proceed, here are some housekeeping and reminders, which many of you who have been going to webinars, you're already very familiar. So this webinar is being live streamed on the EPI-WIN YouTube channel. The webinar is also being recorded, and afterwards, the recording will be available from our website, and the address will appear in the chat. We invite you all to post your name, location, and organization in the chat box. We would love to hear where you're joining us from, and we see already a lot of names and your introductions. Also, please add any questions you may have to the Q&A box, not in the chat, so we can keep track of them. You will find the Q&A box in the lower part of the Zoom screen. Keep your comments relevant to the topic and positive. Please avoid negative, rude, or disruptive comments. We will remove you from the webinar if it happens. So keep these reminders during the webinar. I will hand over the floor to Dr. Sidhi for the welcome remarks. And after this, we will have a short Slido introduction. Dr. Sidhi, over to you.
Thanks, Dr. Lester. Hi, everyone. Thank you one and all again for joining from far and wide, despite your schedules and the different time zones that you come from. So my name is Siddhi Hirve, and I'm the technical officer with the charge of RSV integrated surveillance here at WHO in Geneva. You might be aware that since 2015, WHO has been testing a strategy for RSV surveillance that leverages the Global Influenza Surveillance and Response System, GISRES. And GISRES, as you're aware, is a network of more than 150 national public health laboratories, each with its own national sentinel network of primary care clinics and hospitals. Integrating RSV is a success case for GISRES to look beyond influenza and address the surveillance needs of other respiratory viruses of epidemic or pandemic potential. Today, we have around 90 countries reporting RSV surveillance data to WHO's RespiMart data platform that allows the global monitoring of the RSV situation, along with that for seasonal influenza and SARS-CoV-2. WHO has been working with countries to strengthen laboratory and bioinformatics capacities, especially in low and low middle income countries, issuing guidances, standardizing protocols, encouraging open sharing of genetic sequence data through public accessible platforms such as GISAID and others. In this context, I refer to two important documents from WHO in the recent past: the Standards and Implementation Guidance for Integrated Surveillance of Influenza and Other Respiratory Viruses, which includes RSV, and this was published late last year in December 2024. And the second document is the Operational Considerations of RSV Genomic Surveillance, published more recently a couple of months back. Now, there are too many individuals to call out by name, but suffice to express my thanks to the RSV reference laboratories and GISRUS experts who contributed to the consultations. The development of this document is the first of this kind for RSV genomic surveillance, and this, in fact, is the context for today's webinar. So RSV sequencing guidance and tools are so much more relevant now, as we need to better understand its phylogenetic diversity, especially in resource-constrained geographic settings, to build that genetic evidence baseline to monitor virus diversity as vaccines and monoclonals get introduced. But more on that in the talks to follow. So now let me not stand between you and the two talks to follow any more than I need to, except to convey best wishes from Wenqing Zhang, who's the head of the WHO's Global Influenza Program, and also to assure you that the next hour will be worth your time spent. And thank you again for joining us. Back to you, Lester.
Thank you, Dr. CD. Thanks for giving us a quick background of the GCERS and the network, and also the recent documents that have been published. So as many of you know, we start our webinar with a quick Slido interaction so we can get to know you better. I'm turning over to my colleague, Dr. Supriya, for the Slido.
Thanks, Lester, and welcome, a very warm welcome to everyone for today's EPI-WIN. And, you know, an EPI-WIN really cannot be EPI-WIN without hearing from you. So here's our Slido, slido.com, hashtag 3102258. We have two questions here. The first is, which country are you joining from? I know you've put it on chat, but it always blows my mind, the number of people from so many different countries. And it's great to know that you're joining from all corners. And we hope that you find the information useful and you'll be using it. So the first question, which country are you joining from? Great to know. From Palau to Thailand to Zimbabwe to Sweden, Canada, UK, Pakistan, Croatia. I'm just randomly, saying the names that I spot straight off, but great to know. We will share this with our speakers as well, so they know where you're coming from, and we also hope that you will continue with this work after this webinar. Then our next question is about genomic surveillance of RSV. My colleague Cindy was particularly keen to know that. Why do you think of genomic surveillance of RSV is important? So if you can write a few words on why do you think genomic surveillance of RSV is important? So there are two questions here: vaccines matching, vaccine response, vaccine development. So the question now is not about where you come from, but why do you think genomic surveillance of RSV is important? But it's great to know as well that you've come from so many different countries. Right. So I think to understand the molecular epidemiology of RSV, vaccine efficacy, vaccine matching, vaccine development, vaccine response. Those seem to be the most important ones for all of you. That's great to know. I will leave the Slido on. It's slido.com, hashtag 3102258. In the interest of time, and so that we can hear more from our speakers, I will not share this anymore, but please do continue to put your feedback into the Slido. So over to back to Lester.
Thank you, Supriya, and great to see the network of countries that are joining, and also the general um, knowledge of the colleagues and why this is important. So without further ado, I'm going to turn over to Dr. Thomas Williams from the University of Edinburgh for the first topic, RSV genomic surveillance, operational considerations.
Good afternoon, everyone. Can you see my slides?
Yes, it is clear.
Great.
And
Well,
we
first of all,
can-
thank you very much for inviting me to this webinar. I don't think I've ever been to such a cosmopolitan international meeting, people from really all over the world, and so many of you. So a real pleasure to be here with you to speak today. I've been asked to speak on RSV genomic surveillance, operational considerations, and I'll outline what I'll speak about in a couple of minutes. I've just got some disclosures to make before I start speaking. They relate to my research. I received funding from the European Union and the Wellcome Trust and a number of other institutions for the research I conduct. So today, I thought I'd talk to you about some of the background for RSV surveillance, the burden of disease, the new interventions we have available, and then I thought I'd move on to this new document that Citi discussed, the recommendations on RSV sequencing, and I'll cover some points from there which will be very familiar to you from your work on influenza and COVID. I'll talk about RSV specimen collection, about sample sizes, about the logistics of sample storage, transport, and handling. And then, probably quite importantly for you, Citi mentioned that we've been trying to integrate RSV surveillance within pre-existing influenza surveillance, so ways in which you can include RSV surveillance within the work that you're already doing. I understand that you're mainly epidemiologists rather than lab scientists, so I haven't touched in depth on the laboratory aspects of the new guidelines, but the guidelines are publicly available, and I would urge you to have a look through, either to understand them in a bit more detail if you're looking for particular technical details. Once I've talked about the background for the surveillance, I'll hand over to my colleague Sebastian, who's going to talk about the phylogenetics of RSV. So once the sequences are generated, what information we can glean from them. So as I said, this is the document that Citi mentioned. The recommendations published in June 2025. They're available online. And this was a huge piece of work from people all over the world. And so thank you to all the people who contributed towards this extensive document. WHO has been interested in RSV, as Citi said, since 2015. And the reason that WHO is interested is because there's a huge burden of disease associated with RSV. This is a slide from PATH and the WHO looking at the burden of disease of RSV in under fives. We now think that around 33 million episodes of RSV infection globally every year, 20% under 6 months, 80% in those 6 months to 5 years. We think there are 3.6 million hospitalizations globally every year due to RSV. Again, because infants are more vulnerable to RSV, the proportion of those who are under 6 months increased to 39%. And then it's actually a really important cause of pediatric mortality globally, an estimated 100,000 deaths every year from RSV infection, around half in those under 6 months and around half in those over 6 months. The reason we're particularly interested in those under 6 months is because these are deaths that could potentially be prevented with an effective maternal vaccine. And in addition to the overall burden, it's estimated that 1 in every 28 deaths in those under 6 months of age is due to RSV. And then perhaps even as much as 3.6% of all total mortality in those under 6 months due to RSV and 2% in those under 5 years. So really significant burden of disease. And up until just 2 years ago, no effective intervention to prevent disease. There is, of course, also burden of disease in older adults. That remains even now less well studied. However, This is a study from Europe looking at the burden of RSV in older adults, and you can see there that it's estimated to have a case fatality rate of around 8 to 9%, so not that dissimilar to influenza. And recent data from the UK suggests that the burden of RSV again is not dissimilar to that from influenza, and again the case fatality ratios are not dissimilar. So a big problem in the smallest babies and in older adults. As I said before, we've only had interventions for the last couple of years, and in the last 3 years, there's been a whole slew of effective interventions that we've been able to evaluate in the real world. The first of these was a vaccine for older adults. This is American data showing that the vaccine was effective in adults over 60 years of age in preventing RSV hospitalizations. The second intervention was a long-acting monoclonal antibody called nirsevimab, which again has been shown to be highly effective in preventing RSV disease in small infants. There's other monoclonal antibodies being developed, such as clesrovimab. And then finally, I alluded earlier to the maternal vaccination. And then this is data from here in the UK showing that maternal vaccination is highly effective in preventing RSV disease in the youngest infants. So we found it to be 72% effective in preventing admission with RSV bronchiolitis when rolled out in its first season in the United Kingdom. The cumulative evidence for the effectiveness of maternal vaccination has led the WHO most recently to recommend it to be rolled out globally, either maternal vaccination or nirsevimab, to prevent the burden of RSV infection globally. So the rationale for these recommendations was related to this context I've just presented. There's been rapid development of new RSV interventions. RSV immunization is now recommended for infants, pregnant persons, and older adults globally. And then, in line with that, it was recognized there was a need for sequencing recommendations. So, for molecular epidemiology recommendations, with some very specific goals, which are outlined here. The first goal is to understand the current global diversity of RSV. The second goal is to understand the spread of lineages globally. The third goal is to support the use of molecular diagnostics in order to document the burden of RSV and the effectiveness of interventions. And then the final goal is to inform the development and introduction of these interventions. And so we say genomic sequencing is part of an integrated surveillance strategy to understand challenges or potential challenges to the effectiveness of newly introduced interventions. So a question that I often get is do we really need genomic surveillance? Why do we think there's a risk of vaccine effectiveness being impacted by mutations in RSV? And the reason we think this is because it's happened already. So this is data from subtavimab, which is a long-acting monoclonal against RSV. It targeted site 5. This is a figure from a paper I published a few years ago. Site 5 is in yellow. Nirsevimab targets site 0, which is in red. And so there was a big trial conducted internationally for subtavimab, and it was found to be highly effective in preventing RSV infection with RSV-A, but showed no efficacy at all in preventing RSV infection for RSV-B infections. That obviously caused the trial to not be successful. It caused a product to never enter the market. And then the reason that it was not effective in preventing RSV-B infections was due to mutations in site 5. So this is again from that study in 2018. We knew about these mutations at the time of the study release. And actually, if you go back through the genetic databases with RSV genomic data, you can find those same mutations that made the intervention, the subtavimab, ineffective, were actually documented before the trial started. The trial ran 2015, 2016, but those mutations were already known about and present in 2013. And actually, back to 2009, those mutations were already known about. So 6 years before the trial started, those mutations were present and already pose a threat to the effectiveness of the intervention. So that's a really good reason to be aware of what diversity there is in case we start to see signals that that the vaccines or monoclonals might be affected by diversity. France was one of the first countries to introduce nirsevimab, which is a long-acting monoclonal, to site 0 this time. They had a national monitoring network in the 23-24 season, which is the first season that nirsevimab was rolled out, and they published this really nice paper in Lancet Infectious Diseases which came out last year, was formally published earlier this year, and they, from their monitoring network, looked at all the RSV-A and RSV-B lineages circulating across France, and they found that whilst there was no evidence that any of the RSV-A lineages had mutations that affected nirsevimab binding, there were two lineages, two RSV-B lineages, the BDE1, that's the red plot, a bar in plot A, that actually there were two sets of mutations, I64M together with K65E and N28D, that in a wet lab they found actually nullified the binding potential in nirsevimab. So these lineages are out there. These don't circulate widely. There's some evidence perhaps that the fitness of these variants might be affected, but for sure there's variants already circulating that mean that nirsevimab is less effective. We're hopeful that these won't increase in prevalence, but the rationale for this monitoring is to know what exists and then what is changing with the introduction of the different interventions. These are the objectives of our recommendations. Specifically, the first of which was to outline standards for specimen collection. The second was to improve access to tools for sequence data generation. The third was to ensure timely sharing of RSV sequence data. The fourth was to strengthen capacity in all the labs which are drawing from and centers around the world to make sure this was a sustainable effort. And then finally, what can be used for flu or RSV or COVID can apply really to any respiratory pathogen. So strengthening your infrastructure for RSV surveillance will also hopefully strengthen your ability to respond to other pathogens or emergencies. I've got a couple of minutes left. I'll just quickly touch on what the document covers. We recommended that surveillance be targeted to your local needs. So to use a country's existing surveillance schemes, we said you should try and aim for representative sampling, so by age group, geographic location, time point, and range of disease severity. And we suggested that if you had to pick cases, then to look at clinically significant cases such as fatal cases or breakthrough infections. Another question that we were asked is how much sequencing was needed at a global scale. This was analysis that we conducted together with Melissa Rolfe at the WHO, and then we analyzed pre-existing data and pre-existing prevalence of lineages, and we thought that 46 sequences per country per year would be enough to identify lineages circulating at prevalence of 10% at a country level. But then when you pool that for the 25 countries that are currently doing RSV surveillance in an intensive way, that meant that we could pick up prevalences with a prevalence of 0.3% globally. So acting globally, we can detect these rare variants and understand whether they're increasing in prevalence. The recommendations for storage and transport and handling are very similar to those for any RNA virus. So there's a wide variety of samples you can use. We recommend using viral transport medium to store the samples, and then RNA is quite a fragile virus, so we'd recommend freezing it quickly and only once if you need to, and storing it at minus 70 degrees. We should try and, as I said, minimize freeze-thaw cycles. And then for testing for RSV, there's a variety of different kits available through the IAR or through commercial suppliers to test for RSV. Obviously, we want to make sure that RSV surveillance does not impact on surveillance of other viruses. So this other document, which was released at the end of last year, talks about how to combine the surveillance of flu with COVID and RSV. That's a nice document, and it's got some algorithms for how to test specifically for the different pathogens whilst minimizing costs and maximizing the chance of a positive result. So in conclusion, I think now is a really exciting time for RSV surveillance as these interventions are rolled out. The key to understanding disease burden and the impact of interventions is accurate diagnostic testing. Integrating sequence data generation within GISTRIS will allow us to detect new variants that might in fact vaccination affect this, and it will also allow us to generate scientific insights into how RSV is transmitted as infection rates fall. There's lots of questions around reservoirs of infection, spread of RSV, which we can start to answer with global surveillance. And as I said, I think the expertise developed for RSV sequencing is also really helpful for other pathogens or emergencies. I'm thinking in particular of human metapneumovirus, which is going to be a focus for WHO going forwards. So thank you to many people, too many to name individually, but particularly to the RSV reference laboratories and to the people who review the document that I've presented the recommendations from. And I'm happy to take any questions in Q&A following Sebastian's talk. Thank you very much.
Thank you so much, Dr. Thomas Williams, and thanks for giving us a background also and the linkages of genomic surveillance to vaccine effectiveness, vaccine development, and giving us an overview of the sequencing recommendations, and also the link to integrated sentinel surveillance. So thank you very much. We will now proceed to the next presentation. It will be, I'm now calling Dr. Sebastian Maurer-Straw, who will give us the talk on leveraging RSV genetic sequence data for public health.
Thank you very much. It's my pleasure to follow Thomas, and thank you for the invitation. So Thomas lined out considerations for the surveillance strategy all the way to keeping the RNA stable, which is very relevant if you want to get something out of the sequences. What I want to show you today is how do we get then from the sequences actionable insights. And these actionable insights, they start with how do you get the sequences together? How can you study the sequences around the globe in a secure environment that people are also willing to share? And this is what the GISAID platform is for. It was launched in 2008 with the EPI-flu database. We added tools so that from the sequences you can derive direct insights. And then, of course, we also started with a corona pandemic with EpiCoV, and at the same time, EPI-RSV. And added some arboviruses, pox viruses as well. So the platform itself has evolved, not just in terms of the pathogens, but also especially with the tools that we are using. And I'm also going to show you 3 new RSV features that you can also find in the other tools, but I think is particularly of interest for the RSV community as well. So if you log into GISAID, you see there are already 80,000 sequences from 99 countries. And you also see there is a lot of tools that are available. And I will showcase a bit what the different tools do so that you know how they can help you getting insights. But first, how do you upload a sequence to the system? So there are 3 ways. There can be a single upload, there can be a batch upload, or a command line interface upload. And you see here, this is the form of the single entry. GISAID has a very rich metadata standard that is formed together with the community. Just to give you an example, the sampling strategy field allows you to select from a controlled vocabulary different types of surveillance that you're engaging with. So this is also if you want to normalize and control the data later. I'm showing this specifically because it's a rather new addition over the last 3 years and it's not used by everyone. So I would very much encourage everyone to use it if you can. So add as much information as possible because it can provide additional information for your own studies, but also for the study of others. The study, if you want to publish it, we introduced a new feature called the EpiSet. Imagine you upload a set of sequences that you have studied, and we now provide the capability that you create one single ID, and this ID then serves as the identifier that you can use in your publication. You can take it from the publication, put it to the front of the database here, and then get all the acknowledgement of the submitters in one format. Also, you can reach this then inside the database. So if you go inside to the search and browse interface, you can search directly here. So if you see genomic surveillance RSV paper that has this EpiSet ID, you can put the identifier here and you'll immediately get the sequences here for your own comparison. We also added another new feature. That's the reverse search for the publications. So here on this side, you see, if you follow the drop down, it will give you options for the years, 2025, 2024. And then you click on the year, then you get the option for the months. And in this month, in this case, 2025 July, it gives you options of 4 papers. These 4 papers have used RSV genomic sequences that are found in GISAID. And they have generated this data. So if you click on this example here from a paper from Pakistan, you get the selection of the sequences that were used in that paper. So this is allowing reproducible science and for you to compare the data, as well as for yourself. If you want to get back to your own paper, you can find it there too. One, you submit the sequence to GISAID, a lot of things happen in the background. And there is a global curation team at the different parts of the world that first gets a list of quality features of your sequence, which we automatically add to the annotation. So in the case that there are potential issues, you actually get an email back from GISAID, and we work with you to try to help to improve the data. I've seen in the many messages that come up, there are also several submitters among the audience. So thank you very much for submitting the sequence through GISAID. And it's a journey together that we're in. And a lot of these elements of the quality are new technologies, new viruses coming in. But it allows us also to make more informed analysis to split the data. So I want to mention here the latest addition, which is that we've also annotated all the sequences, not just for the subtype A and B, but also the old genotype system and also the newer lineage system. So the lineage system, a group of scientists, including Thomas, have come up with finer granularity groupings of variants, mostly of the current genotypes. And in principle, you can think of it that way. You have the different levels of resolution, subtypes, A or B, genotypes, lineages. And I'm going to show you also that beyond lineages, you can have emerging variants, which are combinations of mutations or substitutions that become potentially new lineages in the future. And then you go down to the level of the single substitutions. And these were also mentioned by Thomas in his talk about the antibody escape mutation. And I'll show you tools on the platform that allow you to find those. So once you select with the different filters here, your selected sequences, then you can click on this EPI-chart button. And this also helps you from your selection to create simple charts. So for the public health understanding, not just of your data or other data, you want to know, for example, what is the predominant lineage? What is the amount of sequences submitted? From which countries did they come from which continents? Or also the advanced metadata that we have, including what is the distribution of the sampling strategies, completeness of the data, patient status. You also see for how many percent you have patient status available, or gender or age distribution. We provide age histograms and maps. So there's a lot of different options for you to choose from. And it's meant to give you immediate insights on your data and also data that you're interested in that is part of your region or your country. If you want to summarize this in a more simple graph, we have this option of the subtype lineage progression. So here you see, for example, the summary over the last 3 years for all countries. You see A and B pretty much are evenly distributed with different dominances. Here you see the number of submissions that we have gotten from these times. And now if you go into more detail below, you also see the lineage progression. This, of course, is a big mosaic here. So it's often interesting to look at this at the level of resolution of interest to you. So if you take the WHO African region, for example, you can select this here. You see there is a substantial surveillance effort happening, which is really encouraging to see. All these submissions, you see also there is different trends now. So that in recent years, there was an increase of subtype A. And then you can also go into more detail and look at it when the outbreaks were, which were the dominant lineages at that time. So this is a way how you can get more details, and you can go down to the individual country level. I'm picking here Ukraine, and you can see that they have, in recent months, predominantly had RSV type A, and also you can see the lineages. So more data submitted in March and April, and these were those lineage, 80, 81.2, but also a bit of the original 81 first. So similar as you remember, in like the Pango lineages in Corona, there is now a higher resolution way of viewing the evolution of the virus. And this helps with some of the epidemiological understandings. We have also prepared in the platform for you phylogenetic trees from subsamples of some continents, but also globally. Here, then you can see some of the trends and the distances of some of the lineages, but you can also pick different colorings and subsections, including age, although most of them really are from young kids. Because these trees are only subsamples of the data, about 2,000 out of the 80,000, often to get public health insights, you need to know what is your closest neighbor to your sequence in the whole database. And the classical BLAST algorithm has been modified by the GISE team to show the result in a more epidemiologically useful form. For example, we tell you what is the closest hit in the database, and then also where do this hit occur in the map, in the world, and in which time window. This gives you a closer idea if there is a potential transmission from one region to the other, and also what's the general trend of where you get the sequences from or where this outbreak came from. So having mentioned these lineages, there already needs to be enough data available, and they need to be distinct enough so that they are being classified as lineages. What we want to provide in GISET also is the opportunity to look at emerging variants without initial human intervention. So what we provide here is an additional level of resolution, which is the combination of all mutations that are observed in the sequence pool that is submitted across the world. And then we rank those combination or constellations of substitutions based on which one is on the rise. We can introduce weighing factors, for example, for antigenic escape. We do this at the influenza and the coronavirus emerging variant sites. And for RSV, this is also something that is clearly coming in the future. So here you can also see on which continent these variants come. And you can see the second one here is a more predominant in Europe, whereas this one already is in many different parts of the world. So once you find there are these substitutions, you want to know what do they do. In some cases, for your diagnostics, you want to make sure they don't affect your primers. For this, we have the primer checker tool. You can either take a common public primer, like from the US CDC, or also your own primers and check against the database. So I'm not going to show in detail this, because also in your Slido, the majority of you said that the genomic surveillance is important for the vaccine development, but also to monitor if the mutations affecting the vaccine escape. And this is where the RSV server can help you. This is one of our tools where we identify in the data the mutations and also map them to the 3D structure. So here you see the F-glycoprotein in its pre-fusion and the post-fusion form. And this is the different forms that also the different antibodies recognize. So you can see if a mutation in your RNA genomic sequence is in the structure of the protein in a way that it could affect the antibody. And in our database, we've annotated 1,800 substitutions based on its 3D structure information. We've extracted more than 100 substitutions with literature phenotype annotation. This includes higher fusion activity, viral load effects, but also, as you can see here, binding of antibody recognition sites. So this is a way for you to find what is the trend globally of the virus in terms of the lineages, in terms of the individual mutations or combination of mutations, and also link to the literature of what we know about them and the 3D structure and the complex with certain antibodies. So this closes the circle of why we believe RSV genomic surveillance is very important now and allows you to actually gain insights from it. And these new annotations that you see from the quality filters to the lineage, they are done by this tool. So we're closing the circle and feeding this back for you to interrogate the database to ask for these features. So if you're looking for one specific mutations, like one of that Thomas mentioned, you just type it in here in this substitutions search filter. It would be, for example, F underscore and then L119H, for example. And then all the sequences that have this mutation would appear and you can use them for your studies. So I want to close here and thank all the data generators, submitters, and also the users of the database. Very importantly, the GISRIS community with whom we have grown together, all this valuable resource and all the tools. Thank you.
Thank you so much, Dr. Sebastian Straw, and thanks for showing us an overview of the EPI-RSV and its new features and how we can use it for public health, monitoring mutations, and so on. We can see already many questions in the Q&A box. So if you have further questions, we can continue to post your questions in the Q&A box. But now let me give the time to Dr. Kenji, who will moderate and lead us and also facilitate in answering some of these questions. Over to you, Dr.
Yeah, thank you so much, Dr. Lester, and thanks everybody for joining. We have several questions in the Q&A box. We are going to take some of them. We may not be able to take all of them. For some, we've already answered. I think about 4 of them. They're already answered in the chat. So Sebastian, since you just finished, probably I'll just direct a few to you. Then from there, I'll go to Thomas and later on end with Siri. So there's a question, do I need permit from the uploader when using GSAID data in my publication, or a citation is enough?
Yeah, so the concept is really that the submitter continues to own the rights to their sequences. So there must be an effort to collaborate with the original submitter of the data. And there are also mechanisms in the platform that allow you to contact and to establish this. I think it is common sense that if the original submitter wants to tell their story about their data, submits to a journal, they should have the first right to do so. And this is what GISAID supports, and also the journals are agreeing with this, and they have been mediating if there have been any such cases. So for the interest of collaboration and the ability to quickly share, some protection is necessary. And this is a protection that is still allowing everyone to see the sequences for the public health purpose, but the benefits of publication, etc., the rights remain with the submitter.
Thank you so much. And next question, I think it was a participant who had issues reactivating the credentials. So if people have issues related to GSAID account, how or who should they be contacting?
So on the GISAID webpage, you have a help page that addresses exactly this question. If I have account questions, if you have difficulties accessing, I think we have close to 30,000 users now, and 99.999% are absolutely perfectly happy with the system that's functioning well.
All right, thank you so much. I'll come right back to you, Dr. Sebastian, but let me move to Thomas. There are a lot of questions for you, Thomas. I'll just take some of them. What time frame do you consider useful for objectives for timely sharing of RSV genetic data? Example, what is the maximum delay between sampling and publication of the sequences that you still consider useful for public health research? I think the document addresses some of this. Over to you, Thomas.
Yeah, that's a good question. We discussed that in draft document. I think we agree we couldn't give a specific time, but we thought probably in a country that has an RSV season, like a temperate country, then if you're going to publish sequences from one season, you should try and upload them or share them before the start of the next season. So kind of probably like that would be equate to around 6 months between the end of a season and the start of the subsequent season. So we thought kind of that was quick enough to be able to use it, use that information usefully. So yeah, so kind of probably about 6 months, I say, would be a good ballpark figure. There's a balance between the cost of doing a lot of sequencing over several episodes and batching it and doing it all at once. And we thought that probably most settings you'd want to collect all your samples and then do just 1 or 2 sequencing runs, either, for example, in the middle of the season and then at the end of the season.
And Thomas, one of the most popular questions we usually get to is 46 sequences per year, no matter the country population. So can you speak to that?
Yeah, so that's tricky, right? Because there's lots of different countries, huge geographies, huge variation in populations. We needed just a really simple baseline figure. So we chose 46. We thought that was a bare minimum, but clearly if your country can do more, that's great. But we thought as a kind of just a simple ballpark for everyone to use, 46 seemed about right, because that would capture the circulating diversity.
And I think the next question is related, Dr. Thomas. The participant says, I think prevalence can vary seasonally and geographically. A fixed number per year may underpower detection during off-peak times.
Yeah, so that's interesting. We're still not really sure how RSV, this is talking about temperate countries where there's a very specific season, how it kind of is preserved over the off season, whether you get strains circulating over the summer at low levels or whether you get reimportation of new strains. Clearly, if you want to understand that, then you would need to sample in the off season, which would affect your sample size. I think probably those questions are more suited to larger scale scientific studies, just for monitoring variability, which is the aim really of this smaller number. I think you'd probably want to focus on in season samples.
Thanks, Thomas. And again, this one has to do with sample types. Should sputum be included as a specimen for diagnosis of RSV, as there are data suggesting that this is more sensitive than other upper respiratory specimens?
Yeah, certainly I've seen that data suggesting it is highly sensitive. I think for these recommendations, because throat swabs or nasopharyngeal aspirates are more widely used and kind of the methodology is more established, we didn't recommend sputum production, but certainly there's no reason not to do. But our recommendations, we said stick with kind of tried and tested methods.
All right, then CD, I'll probably want to direct this to you. I'm not sure if you answered that already. So at primary healthcare settings in remote areas for low and medium income countries, PCR is lacking for most of the time. Maybe a specific syndromic approach could be helpful to report more of this disease. So CD, can you comment on that?
Yeah, I mean, a syndromic approach can help in the absence of diagnostics in a rural setting, especially for RSV if it's in the sort of less than 2 years or less than 5 years age group, where we often see RSV as the major contributor to the burden that's there in that age group. Uh, I think when molecular diagnostics, rapid tests, they are getting uh, less expensive by the day. And if possible, I think it's resources well spent if RSV is indeed a priority. Back to you.
All right. Thank you so much, Siri, for your response. And this is just going to be a kind of a broad question that has to do, more with policy. I think I see that question has already been answered in the chat. So why don't I go back to you, Dr. Sebastian? The question is, GSA provides invaluable data. However, do you consider reporting bias, e.g., labs may prioritize international reporting of certain lineages for policy or publication purposes rather than systemic uploads? Any questions, any comments from you, Sebastian, on that?
This is a very good question. It is often easy to just lump all the data together. So if during the corona pandemic you would have just taken random samples from countries, you would have picked up only from those countries that have sequenced the most. But this doesn't mean this is the most valuable and balanced data. This is why InGISIT with these filters, when you're in the search interface for all of the databases, you can sub-select. I had introduced the example that was introduced in collaboration with the GISRIS network, the sampling strategy annotation. So if we know the surveillance strategy from, for example, the GISRIS network and the National Influenza Centers that also follow through with RSV and coronavirus surveillance, then we can just pick their submissions that are labeled with, for example, baseline surveillance, SARI, and knowing these criteria, we can have a more balanced view. But to be open and honest is not always annotated. I see some random sampling strategies that you make sure that you have a good temporal and regional spread, even without the sampling strategy annotation, can give a relatively good balanced view. But in fact, we provide you tools because you understand the data and the biases better, that you can try to define your own denominator.
All right, I think we'll probably take two more questions, then I'll hand it back. CD, probably will go back to you on maybe Thomas too can chime in. What do you see as some of the technical or operational bottlenecks in terms of RSV surveillance?
I think I'll just mention a couple. So if you're talking of integration of RSV into influenza, other respiratory virus surveillance system, yes, there are some operational considerations one need to consider which are specific for RSV, and those are related to the case definition to use, the age groups, be it the younger ages or the older ages, and other sort of surveillance components. What's important is, I think, for there to be that awareness that RSV is a public health priority, and to generate that evidence to show it. So integrating RSV, wouldn't recommend it as a standalone surveillance system, but as an integrated part of a national integrated respiratory surveillance system is possibly the best way ahead. Back to you.
All right, Thomas, I want to bring you in for this question because it's more practical. It is mentioned that approximately 46 RSV strains per year are recommended for sequencing. Could you elaborate on the criteria you use to select these strains? For instance, do you prioritize severe clinical cases, regional diversity, or temporal spread across the season?
I think, like Sebastian said, you probably want to prioritize representativeness, so temporal and geographic. But equally, if there are breakthrough cases or clinical cases, then they're interesting to know. Of course, they're just 46 per year. It's hard to interpret those. But yeah, I would say probably temporal and geographic diversity is really helpful. And if there's some way to annotate, if you live in a big country, there's some way to annotate the location, that's really helpful too.
Okay. So I think I'm going to end the Q&A here for now. Other questions we'll try to answer it in the chat, so I could pass over to the to Dr. Lester.
Thank you very much, Dr. Kenji, Dr. Thomas, and Dr. Sebastian. Thanks so much for the discussions and the presentations, and also the new tools, updates, and publications that were presented. Finally, we are at the end of our allotted time. We will wrap up by saying thank you very much to all our speakers and panelists today, the WHO colleagues who have worked on this, and the EPI-WIN team. Big thanks to the working team who supported the presentations for the webinar, including colleagues from the WHO Global Influenza Program, University of Edinburgh, and GISAID. Finally, thank you all for coming and for your active participation through Slido and through the Q&A. The recording of this webinar will be available at the EPI-WIN website, and EPI-WIN Digest, a slide set with key messages on this topic will be published shortly. If you want to keep updated on future EPI-WIN webinars, recordings, and presentations, and the EPI-WIN digests, please subscribe to our mailing list. Both links will be provided on the chat. And we hope you will join us for our next webinars this August. We will have next week, August 19 at 2 o'clock Geneva time. We will have the global applications of the Joint Risk Assessment Operational Tool. On the same week, Thursday, August 21, we will have another topic, RCCE Evidence-Informed Actions for Cholera Management. And 2 weeks from now, Thursday, August 28, we will have a topic on IPC and WASH checklist for Health Emergency Readiness and Response Operations, or HERO. So thank you very much, everyone, for joining us, and we look forward to see you. Thank you all, and goodbye. See you next time.